Sound check, 1, 2. Test. Come on, Twitch. Whatever. Okay, sounds good. All right, so okay, it's definitely working. Okay. So I think I need like an explore locals functionality. No. So hmm. Let's see. What's going on today? Mr. Fourth Dimension asks. Um, well, just trying to get local variable browsing working. I'm trying to figure out um, just exactly the best way to do it. Um, kind of want to be able to have a way to differentiate between the same name variable um, in multiple, um, you know, in nested scopes. Hey, while you're here, and because you're like the only one who's watching my stream, I want to show off some features. Um, so I don't know if you've seen like run to line yet, but I got run to line. I've had that for like a little while. I've also got breakpoints working, and let's see what else I got. Well, here, let me demonstrate that. Continue. Now that I'm demoing it, it really doesn't sound that impressive. But I spent a long time getting that to work. Oh man. So the only things that I've got left to do before I'm considering it like good enough to release to testers is I need variable browsing, and I need to be able to have some sort of configurable run configuration. So right now I'm working on the variable stuff right now. So surely GDB has a way to like differentiate. Here, I'm going to restart. Let me restart here. If I do info locals, I get 4 nested scopes variables. There's no way to differentiate. Oh, thank you. To me, it feels really slow because I was actually hoping to get all of this stuff that I'm working on done Friday. But it just keeps dragging on and on. I also have like a lot of other like little features. Like right now, I'm pretty efficient. Let's see here. Like it's not even registering. Oh, there it is. I mean, if I can filter, maybe I can filter by just my user. Crow. Okay. So OBS is taking up a lot of the CPU, and the GUI, I mean, this is a full OpenGL GUI, and it's rendering, it's using like 7%. That's actually a little bit more than I would like. 3. I mean, it's rendering every frame that I move my mouse, but if it's idle, it shouldn't use anything. Yeah. But I don't know. Well, I'm glad. That makes me feel good about my progress. I still feel like I need to get a release out. So, how are you doing? You doing all right? You working on 4Coder stuff today? Um, in my opinion, do I see a good reason why GDB frontends usually have problems? Oh gosh. Well, I should probably reserve a proper answer to that question after I try to do some of the more complex things that I'm planning on doing. But the fact that you have to have a serialized interface, a serialized text interface to talk to GDB, and it's actually not a very good protocol in my opinion for efficiency's sake. Um, that can cause a lot of problems. Just because of the sheer complexity. Like let me just show you an example here. Let me go to disassembly. Where is I actually don't have a good example of the here. GDB mi disassemble. So, like, let's say for example you want to show the disassembly of a frame or something like that. Here's the format that it can return with, where it's got ASM, ins, address, and whatnot, right? It's got a lot of information there. But, well, okay, before I go into what I actually came here to show you, I just want to say that this is an overcomplicated format to parse. Like, if I'm writing software to parse this format, I have to waste so many cycles just to get to, like, the vital information. And then, like, I'll have to convert hex to, like, a U64. And then I'll have to, like, allocate some memory for this, string here. And then, or maybe I'll have to, like, look up into hash table and figure out if I already have a string and stuff like that. Like, instead of it, like, so there's a lot of duplicated work here. Because we already know that GDB inside of itself has to have a string database to store all this information. And if I'm going to mirror that, I have to have my own string database to maintain my own copy of that stuff. And so, like, it would be much easier if it could just give me some index or something, and then I could, like, talk to its string table and whatnot. But so there's a lot of inefficiencies in this protocol, and it would be a lot simpler if, like, this is just an enum, like a binary enum, saying this is like message 5062 or something, and then I could just look up, and I could do that way faster than doing like a string compare or something like that. And then also, like, once I do that, I don't have to, like, do a forward scan to see, like, when the closing bracket is and whatnot. I can just say, oh, if it's this type of message, then it's going to have exactly this size, and then blah, blah, blah. And, like, if it's variable size, then maybe make that the next argument. It's like, this next spot, this next 4 bytes is, like, the count of the number of items. And then that makes my loop parsing it so much simpler. And it would be a much more efficient protocol to parse. But that being said, I've actually wrote code to parse this stuff, and it seems like it's pretty fast. So I don't know why it would have problems, but then again, like I probably haven't scaled up enough to the point to see these problems. So maybe when those problems come up, I'll run into some sort of problem. And another thing, the reason I wanted to point to this specific example is that the format changes. Yeah, okay. See right here? So here the format is, so like we've got mixed mode, and then I guess this is assuming this is non-mixed mode. This format, takes, caret done, comma, ASM ins, insins, and then it starts this address block, blah, 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 right? Whereas this format here is different. It's completely different. So like it's, it's not completely different, but it's different enough. So I've got, instead of like this open curly, it's source at and ASM line. And then it starts its structure. So so it's the same. You have to write a parser that can expect both. And like the documentation was a little bit vague because like I am always asking for mixed mode. Okay, that's what I was doing. And most of the time you'll get this format. But if you're in a situation where there's no line information and no file information, it won't just emit these values. It will give you this format. So, like, you're expecting this, but then it gives you this. And so, like, I mean, so I don't know. It's not that big of a deal because I basically wrote a metaprogramming language to like parse all that for me. So basically takes, something like this and then converts it into build. It converts it into this. All right. So it's basically like, that's stack frames. Yeah, this is parts disassembly. So it basically turns it into this. Which is, basically like explodes out the code like 1 line for 3 lines or something like that. I'm not sure exactly what the average is. But like, I was originally writing this by hand. And I mean, not exactly like this. Like, it's gotten a little bit more sophisticated since then because I've been doing some stuff in here to make debugging easier. But like, I was writing essentially these switch statements and stuff like that by hand. And it was so difficult. I was getting a lot of errors, like trying to like figure out where I was in the text and stuff like that. So switching to the metaprogram actually made it a lot easier. But like, I don't imagine that people would have, I don't imagine like the creators of Qt Creator or, Sea Lion or stuff like that would have actually gone to the effort of creating a code generator. They probably are just like mapping it all into a string and doing like dynamic allocation and stuff like that to get that all done. Whereas I'm just processing it one character at a time in order so I don't have to do any allocations. Um, but I mean, I still have to allocate for like when I need to copy a string and whatnot. Still trying to figure out the best way to do that. But I imagine the creators of these systems, like the same people who made Qt, are not going to do this. And if they're doing like a whole bunch of allocations and, you know, reference counting for their, you know, stuff, I imagine there's a ton of overhead. Like this is a complicated format to parse, but they're probably like overcomplicating it with their abstractions. So I think all of those things together could make it really unstable. My stuff may still be that unstable, but I don't know. I haven't really scaled up to the point where it's been a fair test yet. Is this a meta program I wrote especially for this? Yeah, essentially. Yeah. I'm actually planning on doing a write-up on it. Because I have a sort of sick sense of humor. I'm calling it bidet because it washes away. It's toilet humor. But it's because I think that this is a very crappy format. And this helps deal with that. So, I mean, it's only 400 lines, but it basically just chews in this stuff and then dumps out, this stuff. And what's real, I don't know if how much you've done with metaprogramming, but I'm especially proud of this because, like, for example, if I'm here or whatever, or like like the way that my metaprogram works is that it just creates a file that I include. So I'm doing it in a very lazy way, and I have to like do all these defines before I include it. Just to sort of like patch up the source to, for my implementations of things. And like, for example, if I do like a typo here, all right, if you notice I got this error down here. But if you notice, the source file is actually pointing to my my metaprogram. It'll jump to line will work. It'll take me right there. So I don't know. It's probably nothing, but for me was pretty cool. Yeah. Is this a Oh yeah. So I want to do a write up on it. And it could very easily be used for like anything, like JSON or whatever. I haven't really done a lot of testing to see if it's actually faster than like a real JSON parser. I imagine it is because I don't understand how it could get any faster than this. Like like instruction wise. Like, I feel like I'm doing the absolute minimum in order to, like, do the branching to figure out what to do next in the format. But there probably is some things I haven't thought of. One thing that I want to do, and, I'm going to do this later as an optimization. I feel like it's overkill right now, especially since I haven't really scaled up to the point where I'd even be able to notice a difference, optimization-wise. But what I want to do is I want to actually start off, have a thread in the background that basically all it does is pulls for, um, you know, new stuff from the GDB file descriptor, and it will just fill a ring buffer, in the background. So right now I have, so I would have one thread that just pre-fills the buffer, and then I would have another thread that would scan through it on this side. So it'd be like, it would have like a write cursor and then, a read cursor here. And so the advantage would be that there wouldn't be any latency. You'd probably cut down the latency in half for the because like right now there's latency involved between, hey, I've made a decision and now give me the next character. If I did it in another thread, then I could have it so that the next character was already in my process's memory by the time I needed to like read it. And so that also, I mean, that's not really that big of an optimization, but really all it wants me to do is, instead of, but the real reason I want to do that is so that I can, so like read car right here is essentially doing a Unix read right there. So it's doing a system call, and there's system call latency in that, and then it's going out getting a read car. It would be much more efficient if I was reading multiple cars at the same time, and that's what I could do if I just had a ring buffer filled. I could just say, give me all the characters you can, and also on the parsing side of it, I don't have to do that. I could just do a jump forward in the ring buffer. So, like, for example, like right here, I'm just doing a decision if there's an A here. And then I'm going to go eat this text. Address equals, quotation 0x. Like, I don't actually get any new information from those characters. Those are just characters that are in my way before I can actually get to the hex value that I want. Like, they don't add anything to my ability to parse it's not giving me any valuable information. Like, the only valuable information was the leading A. I know that nothing else can come after that except for address. And if I had it all in a ring buffer, then instead of actually doing anything with these characters, I could just jump forward the number of characters. Like 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, just jump forward 9 characters, and that's like 9 cycles, or just save, like right there. So, or 9 instructions. Or actually, it would be much more than that, because each one of these instructions is like, calling out, doing a system call, and whatever. So, okay. You're in need of a vacation week? Man, I wish I had a vacation. I'm juggling this and stuff I'm doing for work. I really can only do this on the weekends, and so this is further behind than I would like, and my stuff that I'm doing for work is further behind than than my employers would like. But like, I'm so sick of working on that stuff. I wanted to work on something else, so that's why I'm working on this stuff. But I've been having trouble focusing in July. I made a lot of progress cleaning up. Awesome, that's good. In preparation for MacPort. Awesome, I'm excited about that. To be honest with you, the main reason I switched to Linux is so I could use 4Coder. I was so tired of using Emacs, and I use a Mac for my day-to-day programming. Even though I mostly develop Linux applications, I like have to have them like running on specific hardware anyway. So I'm like always doing remote development on them. But so it really doesn't matter like what machine I'm actually running on. I can always cross compile for them. But the but yeah, I've had a much better experience than using Emacs. Just because I'm the kind of person who just gets frustrated when I have to use eLisp and I'm doing all kinds of customizations and stuff like that. Nice. Text-based interprocess communication. Yep, that's the big problem. There is also some other issues that I think are... I think that the problem with GDB front ends is a little bit more... there's more to it than just the text processing. I think that, GDB itself, can be a little bit buggy. I think the version that I'm using isn't very buggy. But I think like a proper solution would bundle the debugger and would bundle the GUI and GDB with it. And also like, I'm also, by the way, this text processing thing, I'm actually sort of getting to the point where I'm thinking that it would be best just to patch in to GDB, like just to like write some GPL'd patches into GDB and just write a better implementation of a protocol than this, something that would be easier to parse. But there's probably some other stability issues that I just haven't seen yet. I have noticed that GDB itself just crashes sometimes. The version that the GDB 8 that I'm using, I think it's GDB 8 that I'm using, hasn't crashed. So I'm just assuming that, yeah, I am using GDB 8. I'm just assuming that a lot of the crashes are just because you're stuck in a distribution using an older version of GDB. I don't know. Did I answer all of the questions? Sometimes you can avoid branching with a LUT. Not sure if it would work here. I'll link you one sec. Nice. Okay. Let me see if I can copy and paste. Unfinished paper. Okay, I think I'm going to have to read this later. Thank you for the link. I was unaware of this. Yeah, I'll have to check it out. The main reason I didn't use Lex and Flex is because I couldn't frickin' understand how to use them. Okay, that's not exactly true. Here, let me do wiki parser generators. Okay. You get a frickin' table like this, and I don't have a computer science background. All right, I have no idea what DFA is, or DFA direct, DFA table. So I go into them. And I'm like, oh, okay, so this is basically just creating this, um, state machine. And, or like LL, lar, lal, whatever. And I don't understand like what any of that stuff is. And I could go research it. But like for me looking at it, I'm like, dude, this is such a simple problem. Every decision could be made based off of the next character. You know? And I don't know. That's kind of what my frustration with all of it is. And then like you find something that like a lot of people would like, I think a lot of people use Bison. Or Yak or whatever. What did he suggest? Lex and Flex. I think is that something different? Flex. No, regular languages. Okay. But like it's not there's like so much like argument as to like which one is better, and then I would have to learn this format and stuff like that. And for me, it was so much easier just to write something than try to like understand what all of this stuff was. And that's like my biggest frustration, I think, with a lot of stuff, with libraries and stuff these days, is that like a lot of the stuff that they're doing is just so simple. Like this is what I said. It was like 450 lines of code, 432 lines of code, and it does exactly what I want. Like I probably spent like a day on this. I mean, well, actually, it's different because it's probably a little bit longer because I've gone in and added stuff to it. But I don't know. And this also sort of like solves problems that, I wanted to solve that I don't think a normal Lexer would want to solve. Like, I don't know. Oh, let me grab out of that. So, I don't know. I'll check out that paper. Thanks for linking it to me. In case I close out of this, I'm going to save it and add it to my to-dos here. To do, read, nothings. Okay. Fundamental CS theory terminology. Awesome. I would think I would appreciate that. There's a lot of things that I just don't know about. Like, watching Casey's video, I have a pretty good grasp of like linked lists and stuff like that. And I've also like done independent research. And so like I have a pretty good idea of like, different kinds of trees and stuff that I could use. I've never needed to use a tree, like a red-black tree or something like that. Well, okay, so I do everything the stupid way until like I run into some sort of problem. Like, I'll just use linked lists because that'll pretty much work for everything. Like even though these frames are they have an order to them. They could just be like indexed like an array. That would probably be much more efficient. Like just stepping through a linked list. Like if I want to get to the third frame, just walking the linked list 3 times is like just fat. Like I haven't really run into a situation where that's my slow problem. So I never know why I would want a tree. Hash table, array, or linked list covers, all needs. Yeah. Um, I should use a hash table. I think I'm gonna have to use a hash table for this project. I actually haven't had a project of scale where I had needed to do a hash table yet. Um, well, actually, no, that's a lie. I did implement a hash table for one of my log parsing things that I did. Um, but I don't even know if that was absolutely necessary. I don't know. Oh, okay, so let me figure out what I was doing. Okay, so I need to enumerate variables. I'm going to close this for now because I'll be distracted by it. I need to enumerate variables here. Okay. So let me just go ahead and write the code to just dump all the variables from a certain scope. So no arguments, info, locals, message scope, 1, 2, 3, 4. Yeah, it sort of bothers me that there's no way to differentiate between these variables. I mean, obviously, there's a way to list locals, addresses of locals. Well, see, that's not. I need something that doesn't work based off the name. Info address. So I have to use the Python API to do that? GDB, multiple locals, same name. So this has been closed, fixed. I don't want to have to like stop through the line, stop the debugger in every line. The debugger should like be able to know. Maybe help info arguments, or help info locals. Thanks. That's great. You know what? Maybe we just need to consider this an advanced feature, and I'll figure out some other day. There's no... Yeah. Okay. If you're naming variables the same way, same thing on each frame, within the scope, then... Well, okay, so that's actually not the attitude to have. Because I guess the main reason why I wanted this functionality is because sometimes you have variable shadowing and you're just not aware of it. And then if like the locals viewer could just tell you that, then it would be better information for you, debugging wise. But I don't want to get hung up on this because there's more important things to do. So I'm just going to do this, so list, oh, come on, list cards locals. Oh, well, while I'm through here, I might want to just do a last ditch attempt. Collect values of the given expressions. Stackless variables. Let's see here. All values. What does all values do? Okay, right. Prints the values, or simple values. Prints the name and the type and value for simple data types. Well, I guess I want to write a parser for all of the data, no matter what, anyway. Here's another question. What will it do if there are multiple variables? Okay, so this doesn't work like I was planning. Okay, so what I was thinking about doing was be able to like say, here's the frame, give me all the variables in that frame. But see, that wouldn't work because the number of variables will change. The list of variables will change depending on like where you are in the source. So it actually needs to get it every time the debugger stops. Which is, I guess, is fine. I don't know. Let's see what that looks like. So stack list variables. Let's go ahead and kick off that. So reloadable. Let's go here. I think when I'm listing out the frames, I'm going to want to have this idea of a variable. It's getting super hot in here, so I'm going to turn on the fan. The fan's already on. It just is not on enough. And okay. So stack frame, we're gonna have a struct that's just a variable, and it's going to have a name, and it's going to have, let's just say that it'll have what do I want to do for the cached value? I think I just want to store it as a string for now. So I'll do like here cached value as string. And then I guess I want next. Yeah, so variable start next. Okay. And then, so stack frame is going to point to some locals. Okay. And then I think I want like a get locals command. So get locals command context, and it's going to take a, it's going to have this idea of a frame number. I'm actually going to move that around. It's probably going to cause a problem. But whatever. Thread frame. And then it's going to need to take a pointer to the stack frame object. Actually, it doesn't need that. It's redundant. Okay, because it could just get it from the stack frame. Okay, so stack frame frame. Okay. And then here get locals get locals. So I need like some sort of get locals implementation. Actually, before I do that, I want to go ahead and where is my dispatch? Process command here. So I'll do a process command. Well, actually, before we do that, let's do this guy, and it needs to do a get stack, get locals, and then get locals. Okay, so now we got compile errors. Let's fix those. Variable stack frame. Okay. No member get locals in generic command. So, yep, get locals. Oh, oops. Get locals. Process command. Yes, no matching function call. I agree with that. Let's make a matching function call. This needs to do a get locals and what do we want to do here? We want to execute this command, stack list variables. Is that what we want to do? Yes. All right, and so it's just name and value. Okay. I think we want to do all values. So 1 is all values, I believe. Okay. Oh, I have to do like thread 1 frame %d and then 1. Okay. And then parse variables, stack variables. Okay. Or parse locals, I should say. There you go. Be consistent. And um, okay. So here, what I need to do is I do CTX frame level. I believe that is correct. Comma. We need a comma. Right. So let's go to the spec file and create this routine here. And okay, because I haven't figured out what I want to do with my strings yet, I'm just allocating them all on the stack, on the heap, which means that if I'm dumping frames, freeing the frames, then I need to make sure that I go ahead and free the old variables, strings. So I'm going to do that before anything, because if I don't do it, I'll forget. And then I'll have a memory leak, and I have no idea why. I don't especially like putting them on the heap. But I haven't quite figured out the best way to do it yet. I don't know. That's probably what I would use a hash table for. Maybe. Okay. Okay, well, so the way that from my understanding, memory arenas are really good for like if I have a job and it needs like some work memory, and I could just give it some work memory, and then when it's done, it just gets rid of everything, the whole arena, right? But that doesn't really work in my debugger because, oh my gosh, you're totally right. I just didn't think about it until now. Okay. My old line of reasoning was that I couldn't use a memory arena because I was going to have to go back and forth. Like, there was no clear distinction between when I was going to need this memory and when I wasn't going to need the memory. Like, I could have needed it, like, at any point in time in the future. Like, so, like, my point is that, like, this frame here needs to store this link to this file name. Alright? And the file name has to be stored somewhere. Or the function name. That's a function name. But, like, here, for example, here's a better idea. Oh, this is exactly why I needed it. Yeah, okay. Okay, so the memory arena would work in this case, but it would not work in this case. Or at least I couldn't figure out a way to make it work in this case. Sorry, it's all... I'm swapping it in now. And maybe you have some ideas on how I could make the memory arena work in this case. But Um, I I think I can get it to work with the whole stack frames and variables thing because I could literally just dump the arena every time we stop and then start from scratch. And I think that would be a good use of the memory arena. Like, yeah, I think that's perfect, actually. Um, and I'll actually probably switch everything over to that as soon as I'm done talking. But I could not figure out how to get memory arenas to work in this format because, okay, so this is a database of breakpoints. All right. And there's a lot of strings here. And I know this looks redundant, but I haven't quite figured out a way to like get it not to be redundant yet, or I haven't established that you can guarantee that it couldn't be redundant. And also, not all of these strings are filled out right now. So this is what's in a breakpoint. Come on. Where is my data? There's my data. Okay, this is what's in a breakpoint. It's got a car star for at, which is like the what is at? Hold on. Break insert. Are you gonna give me the... Oh, right here. Okay. What is at? At is the... Oh, it actually holds the address. Oh, no. It holds the address, possibly followed by a symbol name. And if I recall correctly, build, what is this? Debug redump. Let me see if I can do an at. Colon. Yeah, okay. The documentation says address, but it's actually square bracket or angle bracket function name angle bracket. So that's why it's a string. And let's see. So we got at is a string. Function name is a string. File name. The full file name, which I don't exactly know what the difference is. I just put it in because I'll figure it out later. An original location for a pending request, and pending, I think, is like the... So like if you do a breakpoint for something that's not there yet, this would be null, and then this would point to like a textual representation of what it's searching for. And then once it found it, then I think that this would become... I don't know what it is. I don't know. This is probably redundant, and like a lot of this stuff could probably be put into like a union. So we don't actually need spaces for all of it right now. But the reason I put it all discretely is because I don't actually have a full grasp of what GDB is going to send me, because I haven't quite got to the point. So I'm just sort of like grabbing everything at this point. But the reason why I'm storing these on the heap is because these breakpoints have no lifetime. or discernible lifetime that I can see. Like, if I was so like a memory arena works great for a frame because, or like I could just dump. I just have this idea of like a memory arena for every time the program stops. Okay, and then so all of the things that would generated for when the program stops goes into that memory arena, and then I just dump it when I want it, when next time I stop, and that's I think what I'm going to do next. But the problem with the breakpoints is that these have to exist for the lifetime of the program, or not. Like, there's no easy way to like figure out when these breakpoints are gonna like if I continue, these breakpoints are still around even between frames. And then but if I disable it, all of a sudden it's not needed anymore. Boom. So like the entire lifetime of those breakpoints is like random. And so that's why I'm putting them on the heap. And if you have a better way to do that, I would love to know. I would love to hear about it. The way that what I was thinking about doing, if nobody came up with an actual better way to do that, then what I was thinking about doing was creating like my own section of like instead of allocating it on the heap, I would allocate them out of my own allocator, like just for strings. I would just create like a string allocator, and it would basically have a table of like pointers, and I would have like a linked lists of like 4K buffers, and then I would like allocate out of those 4K buffers chunks for strings, and then when strings were removed, I could like defragment the 4K buffers, and then like basically say, oh, these are all the strings that are in this 4K buffer. Let me rewrite the 4K buffer again by like only like the top, so that all the empty spaces at the end, and then I'll just use my string table and patch up the pointers in the string table. That would be a way to do it and still have the Casey style of we're going to do one allocation per program or something. Or not necessarily one allocation per program, but it would also be, because you don't want to do one allocation per program because, sometimes you have a 1 megabyte workspace need, and sometimes you have a 16 gigabyte workspace need, and you shouldn't lump everybody into the same, category. But I could still get away with it by only doing allocations, like when I need to, not willy nilly, like everything on the heap type of thing. So the breakpoints are kind of the thing that needs something fancier. It's too bad you can't query that info like the strings on the fly. I'll think about it a bit. There might be a trick. Yeah. Yeah, let me know if you got an idea. Yeah. But like instead of doing one allocation, at the beginning, you could do like I could just have this idea of like these are my raw memory chunks, and just keep like a linked list of those, and then allocate out of those. You're basically, I guess, implementing your own heap allocator at that point. Which, I mean, I feel like it has its own benefits because at least then you're not going out to the operating system all of the time. And you could be a better steward of your memory. And plus, you could also have like more fine-grained control over it because you can say, I want all of my strings to be allocated out of my out of this string allocation system. Or I want all my large blocks to be allocated out of this large block allocator. So, um, anyway, okay, so Mr. Fourth Dimension, Alan, thank you for making me realize that I could put all of this stuff into a memory arena. Because my brain was still on breakpoints. And I was doing heap allocation for breakpoints. But I don't need that because frames have a reliable lifetime of memory requirements. So, or I should say predictable. So I'm going to go ahead and do that when I come back. But I'm going to take a 5-minute break because I have to use the restroom. I'll be back in a few minutes. Thank you for watching. Test 1, 2. I always have to check the audio whenever I restart FFmpeg because sometimes it doesn't work. Testing the audio, waiting for Twitch lag. Okay, it works. Okay. All right, so where are we at? We had just had the stream meta consciousness of all of us together had come to the realization that we can use a memory arena for everything pertaining to when the program stops. Actually, hold on. Is that really true? Because okay, so obviously all of the values of like every stack frame and is obviously tied to the lifetime of when GDB stops. Like every stopping point. Let's say maybe we should call it stop memory. Oh, hey, Sir Klaus, SKZ, Zach Klaus, SK Zach Klaus, Zach Klaus. I don't know if I'm saying it right, but thank you for watching. How are you doing today? Okay. So obviously all the stack frames and also like the listing of threads and everything can easily be tied to the lifetime of stopping. So that's very predictable usage of memory. But what about like... So let's go back to the current example. Like the thing I was just trying to implement, variables, right? Like, so locals are tied to the frames, so that can be predictable. But, I think I'm getting to the point where I'm like overthinking it, and I should just code it. And if it works, it works. If it doesn't, it doesn't. So I'll probably just code it here in a second. But I spent most of my life writing stuff in Python, and with Python, you have to do a lot of work to like try to figure out if your program's going to crash. Because if you have a huge program, then you have no compile time, like error detection, and so you don't want to like have like some sort of like unnamed variable or something, and you're like in like 30 minutes of running the program or something because it has to get to that specific state. All right. Anyway, sidetrack. I'm used to overthinking things, so I apologize for that. It's probably an instance of that. But I'm trying to figure out right now if actual variables fall into the same category as stack frames in the general sense, because like you're gonna want, in some senses, you're gonna want variables between stopping. Like you're gonna want to keep a list of things pertaining to variables between stopping. And also, inside of a frame, you're going to want to keep track of. You're going to there's going to be some randomness as to what you're going to want. Of what variables you're going to want to see and stuff like that. Like, for example, like let's say you've expanded out some big list. And so because you've expanded out some big tree of variable structures, and since you've expanded out that tree, you've done a whole bunch of allocations in the frame memory for like the strings pertaining to the values and names of things. And then once you like collapse those trees, then you're gonna want you're gonna want to like free those, or you know what, you could just say that like if you ever run out of frame memory, then you basically you just forget all the stuff that you'd free. You just like skip over it and ignore it and just start at the end of your frame memory. And then if you ever run out of frame memory, then it'll just wipe the whole memory arena and just go back to GDB and recreate everything. And then it'll basically be defragmented at that point. Because it'll be, all your free spaces will get filled and everything moved from the end to the beginning. I don't know. So I'm just going to start coding and see what we got here. All right. Okay, so I already have this concept of I already have this concept of different memory arenas. I have frame memory and main memory here. By the way, I'm going to start calling them what I usually call them, and that's just memory stacks. Because that's just what I've put on them. What I've been calling them. So I've got that. I don't think we really want frame memory anymore. We want it to be like stop memory, for lack of a better word. I don't know what to call it. Stop memory. Okay, and so that caused a whole bunch of problems. What do we got here? So this is in my metacompiler. Which isn't related to anything I just did. Okay, alright, whatever. Let's debug it. Um, run. Segmentation fault. Okay. So it's null. What's my backtrace? Where am I? What the crap has happened that would affect that? Oh. Okay. That's what's going on. Okay. Yeah, alright. I need some better error messages from a meta compiler. Okay. Whatever. And by error messages, I mean not crashing, not seg faulting. Okay, that's fine. I'm just gonna go ahead and assert 0 right now because this function is essentially not implemented. And all right, and then we've got stop memory. No memory name, stop memory. Okay, right. So we need to actually go up to here. And do frame memory. We'll just stop memory. Also, I don't really know what the point is of the selected frame stuff. I want to rename that just to cause compile errors. Now, one thing at a time. One thing at a time. To do. Get rid of this. Rid of this. Okay. One thing at a time. So... Oh. This is a mistake. It needs to grab it from memory, not frame memory. All right. Parse instructions. Yeah, that's tied to the stop, so we'll call it stop memory. Parse disassembly. Yes, that's tied to the stop memory as well. And frame memory here. What do we got? Oh, okay. This is what is dumping the stack memory, or the frame memory. So, we're going to call it our stop memory here, stop memory base. Okay. I think that's actually a mistake. Now that I think about it, yeah, frame memory space, it should be stop memory. Okay. Okay, so our stack frames here. Um, well, hold on. Stop memory. We actually don't want to do this anymore here, because we do want the stop memory to exist between render frames. So let's get rid of that. And now we are going to tie that to a stop here. And we also need to get rid of our free stack frames. Okay, so, and then here we are using stop memory instead of main memory. Here, and we are going to alloc to there. And because we're using stop memory, we do not need to free any of the stack frames. So let's get rid of the free stack frames button. Free stack frames, or function. So stack frame count equals 0. So my lovely wife has told me that my tea is ready, so I'll be right back. 1 second. Actually, I'm just going to leave it on because I don't want to mess with the FFmpeg. So I'll be right back. And I have tea. Okay. Thanks, babe. Okay. All right. So get kind of caught up in like all of the things, like multiple things at a time, instead of like just the thing that I'm trying to solve right now. But anyway, so this guy needs to go away. I'm just going to underscore it right now. I'm going to go ahead and just like inline some of this functionality here, because down there, well, and then I'll just get rid of this. Yeah, let's get rid of all that. And then get rid of that guy. 3 stack frames here if we are running. Okay, so I think before we stop, we need to initialize some of our stack memory here. And there we go. I'm not sure what I want to do here. I think I just want it to live from the time it started to the time from the time it stops to the time it stops again, rather than from the time it stopped to the time it starts running again. So I'm not going to do anything when it starts to run again. So, okay, so that I'm running now. So I'm compiling now. So I think that just works now. Well, except for the fact that still allocating stuff on the heap. So let me fix that. To change from allocating on the heap, all I got to do is change this from main memory to frame memory, or to stop memory. And ooh, I also want to do stack frames free. You know, because I'm allocating all the frames every frame, I don't even need a free list. Right? So I'm just going to get rid of this attribute. And so it'll never do a lolloc. It'll just do a straight up alloc then. I think I want a couple different versions of this. I want an alloc with a free list, and I want an alloc without a free list. So alloc2. So we're going to have a falloc2. And then a non-free alloc. Well, I think we just want an alloc2 and a non-free alloc2. Okay, but I'll put an underscore in front of this for now. Just because I want to generate some compile errors wherever that comes up. And so this will pretty much always do an alloc here. And so this is just going to short circuit into this. We're going to do a falloc append and a non-alloc. And this guy is just going to do the same thing. Okay, so that's what we want. And actually, we don't have to worry about that because if the free list doesn't exist, then it's the wrong type. So it's automatically solving itself. Okay, so my program's still run. Yes, it looks like it does. We reached the abort here. Let's see, that's 226. FIFU FR. From. Are you serious? Is that in the documentation anywhere? Where was that? From here. Function start from. Okay. Let's go look at the docs. It is in the docs. I just missed it. Okay, so we've got level, address, get rid of this guy. Level, address, function, file, full name, line, from. From is the only one I'm missing. Interesting. Okay. I can handle that. From equals oh, and I need to change these from read string heaps to just read strings. Right. Yep. It would be really nice if Clang like took me to the struct definition. Is that like a feature? I feel like that should be a feature. Clang error struct definition. Hmm. Okay. Can't have everything. Segmentation fault. That's awesome. What have we got here? Stern copy. Right. Okay. So full name. It's empty, so just do like open view to source code. Needs to handle the null case. What is this? Stack frames? Test GUI run. 1210. Okay, so I think I want to like a generic like expect this or run or an error. Okay, so actually, do I want to use the meta compiler for this? What would that look like here? That would look like routine, parse, running. Test context. So we do like a branches right away. And we would do, let's get rid of this. We'll do a branch is mandatory here. Then we'll expect running. Or we'll do expect error. Error, comma, message. And because well, okay. Buffer append text pipe rest of line to console. So we'll do that. So we'll do a literal buffer append dude got an error. Don't want to mark the debug dump some way. Well, I'm just going to say got an error. And then we're going to do a literal pipe rest of line to console. All right, so it's having trouble. So the code generator is having trouble on line 89. And what exactly is it having trouble with? Bidet. Branches. So it's still on 77. Okay, so the parser generator is having trouble with the fact that the first thing in the function is a branch. So um, I'm getting pretty tired, so I think I'm going to take a break for now. Thanks for watching. I'll probably, I don't know, I'm not sure how long of a break I'll take. So, anyway, thank you for watching.